In this case, the consequences weren't that serious, but too much slack between a bolt and its mating surface can have a variety of serious problems for equipment or operations. Slack can cause accidents resulting in injury to personnel or damage to equipment. To understand why there is slack in the first place, we'll have to take a closer look at how bolts are fastened. To fasten a bolt to a support, the hole in the support must be larger than the bolt itself. If the bolt is exactly the same size as the hole in the support, it simply won't be able to slide in. This means that in a conventional pin support connection, the full load is being taken by a single point. Once force is applied to the bolt in this configuration, it will begin to deform. Once this process has started, every time the system is loaded, further deformation will take place until the bolt support connection eventually fails or has to be rebuilt due to excessive wear. Here we can see that ovality has become a major problem, and this bolt will clearly need to be replaced. One way of solving this problem would be to make the bolt exactly the same size as the hole in the support, then install it by freezing the bolt using liquid nitrogen. Perfect! Or is it? Although the installation process would have gone smoothly, it's a completely different story when the bolt has to be removed as a result of damage or standard wear and tear. Realistically, the only way to remove the pin would be by torch cutting, which could turn out to be a very tricky and expensive operation with no guaranteed result. This is where the Bondura pivot pin technology comes in. Assembly tolerance is crucial to a conventional pin support connection. The contact surface between pin and support can be derived by projected arm length in the Hertz contact formula. An increase of assembly tolerance from 0.04 mm to 0.1 mm will reduce the contact surface between pin and support by 78% and thereby increase the contact stress by 4 times. The Bondura technology allows us to use a larger assembly tolerance, and after the installation is completed, the clearance between pin and support is 0. This gives us a contact surface of 360 degrees and a load distribution surface in the supports of 180 degrees. Here we have a conventional bolt assembled into a joint. This is how it sounds when there's slack in the system. You can just imagine the problems that would occur if a few of these joints had been linked together. What's brilliant with the Bondura joint is that you get 180-degree distribution of the load in the joint due to the tapered sleeves on each end of the pin. As the screws are tightened, the sleeves on each end of the pin are wedged into place, which eliminates any slack in the system. The Bondura joint can even reduce the slack in equipment where there's ovality in the supports. Simply tightening the screws will force the holes in the support to regain their original shape as the tapered sleeves move into position. Now this is a solid joint. Today, Bondura joints can be found in a variety of different areas on heavy machinery. The bolts are all certified in accordance with API Spec 8C and FEM regulations, and have also been type certified by DNV for use offshore in any kind of joints. Bondura pins used on cranes and other lifting equipment are certified in accordance with NS 5514 and the rules of certification of hoisting appliances. Typical joint positions would be on cylinders and booms. Bondura pins are used by equipment manufacturers and contractors within construction and mining industries as well. If you're focusing on reducing unscheduled downtime, Bondura will make the difference. The Bondura technology will become the new industry standard for mechanical joints. Use joints that are manufactured to be precise. Use Bondura and you'll improve safety while saving both time and money.